So this is my favorite car battery. I got it when I was about 11 years old, and it's from 1992. I've had it for like 9 years now. And I've learned a lot from it, to be honest. But unfortunately, it died just a couple days ago. I spent like 3 months desulfating it. It was getting really good. It was getting more and more capacity. Then all of a sudden, it just decided to short out on me. Cell 1 shorted out. And then the other cells kind of went a little bit wonky. Don't know. But I've decided not to give up, because it had worried me that I do use this not for starting. I use it for like powering my laptop when I go camping and stuff like that. So starting batteries don't last too long like that. I mean, it lasted 21 years. That's pretty good for it. But what I've decided to do is open it up and replace the lead and acid with lithium ion cells. I happen to have quite a few bum lithium cells laying around. They're not shorted out or anything. They just don't hold much capacity. But if I filled this thing with bad lithium ion cells, it would still be lighter and more powerful than lead acid, and I could discharge it fully without having to worry about all the problems with desulfating it and all that crap. Well, that's interesting. So I'll don my gloves and I'll pour it into this polypropylene bucket. One quick shower later, and we're back in action. Didn't burn, just got a little lead on me, that's all. Then again, I guess that acid did have a little bit of life in it, because it started eating through my tripod. All where it splashed onto it. Interesting. Yeah, at any rate. So I'll let this drain for a little bit. So I rinsed it out, and I neutralized the acid with some baking soda. And it's looking pretty good. And I can tell why this side broke, because look at all the plates in there. They're all slanted and bent. As you get further down here, they're straighter. Well, maybe not that one, but that one's pretty straight. But you can definitely tell why that one failed, because it looks all warped and stuff. So, let's try to open it up now. Last night, me and my mom used the Dremel to cut along here, and we're cutting off the bottom of the cells, and as you can tell, they are really nasty. A lot of junk buildup inside here. Nasty sludge stuff. Cell number 2 looks really clean. Well, compared to the first one. My counting is a 20-year-old battery, so it looks like it's brand new for that. Well, let's continue. So now I'm going to have to figure out how to get these plates out. I really don't want to make a huge mess, but it looks like I might have to. So after a little while of fiddling around with this, I forgot to film it, but anyway, I figured out a way to get the plates out. I turned it upside down, and I banged on it, or I put this into the acid fill holes, and I banged on the plates and the plate connectors, and that broke them loose, and then I was able to pull the packs of plates out. And thankfully, they weren't damaged too much, so I can put them underneath the microscope later, and we can see the difference between the surface of the lead on the plates. So that'll be another video. Wow, it actually only took me about 20 minutes to get the cells empty. I'll be sure to categorize which plates went into which cell. Like that was the really, really bad cell that shorted out, and that was one of the ones that was really good. There's obviously a difference in color in that, and I'll categorize those and keep them out, and make another video where I put those underneath a microscope. And these cells, they're pretty nasty inside, because I pretty much killed the plates, but I believe that's probably good enough for a start. After about an hour of cleaning it, it is now clean on the outside. And it is clean enough for me, I believe, to take inside. And here's a look inside of the cells for you guys. That's the bad one. You can obviously tell a big difference between the bad one, better one, bad one, better one. And I was really fretting about how to fit the lithium ion cells in there and how many I could fit in there. But as it turns out, if you have them configured like this as a big row, they do fit in there somewhat good. I believe I can easily get two rows of lithium ion cells inside of there. So mostly what I'm going to be using this battery for while I go camping this week is running my 700 milliamp 12 volt fan, and even these running in series, or these rows running like they are with 6 by 3 in series and parallel. That would run this for probably a good close to 10 hours, which would be perfect for what I want. But what I plan on doing is, instead of running it at 12 volts per cell, because remember there's room for 144 cells inside here, I'm just going to fill up one cell as it is right now. And so the battery will be 8 volts. And then what I can do is I can use my trusty voltage step-up transformer and get anywhere from 10 to 80 volts if I really want. Sorry, I forgot my tripod, but the time-lapse of me soldering these would have made the video even longer anyway, so oh well. I'm going to take some of this 12-gauge wire and solder it across here. That way it'll make a flexible bond, and then I can bend it up because the copper wiring is flexible, and then I can tape it like that. And that will be an 8-volt, 16 amp hour battery pack. And here's the battery pack. It's pretty much all finished. I have to cut some of this cardboard off. It's just a little spacer I put in there. But yeah, it should fit in there nice and snug. Although, I'll have to bend these wires over. Just realized that. So now I got to figure out how to hook this battery pack to the terminals on the battery. Well, I gave up on trying to solder wires under the terminals from underneath, so I just took the lazy route and put alligator clip wires in there. Works good enough. So now that this battery pack is all put together, let's add some quick connectors and get it charging. Usually on my projects I put the male connectors on the negative and the female connectors on the positive. I'll be charging it at 1 amp. Now let's add a battery pack thingy. So now if we check the voltage, we're getting the full 8 volts across it. Awesome! So unfortunately this battery's terminals are already corroded, so anytime I connect something to them, they get a resistive connection. So I'm just connecting to the wires on the bottom right now. And I'm running my multimeter measuring the amps of the current going through it. Now, the 8 volts, the native 8 volts of that battery pack isn't enough to run very much. So I'm using a little $7 step-up transformer and stepping it up to 14 volts. I'm running my little fan off of it. It pulls about 1 amp from the battery, which isn't bad at all. And pulls about 1.5 on the high setting. Well, I gotta say, I'm pretty happy with how long this battery lasted. Unfortunately, I forgot to charge it all the way. That kind of would help, you know. Anyway, but I still got like 14 hours of fan use out of it. I just turned the voltage down to like 9 volts on the fan. But on this battery, the reason why this battery pack didn't fit all the way up in there was because there's like the electrodes that are made to pass the current from cell to cell on the old ones. Well, anyway, I think I'm just going to cut out one of the walls, or 3 of the walls. Cut out this one, this one, and this one, so I'll have a bigger block. And I'll probably cut off these ending parts too. And then I'll probably have enough space to put a base on the bottom of it, or plastic thing. I don't have things sticking out. Also, if I make the cells wider, I could get a soldering iron in here and solder onto the bottoms of these things. I don't want to take out all the walls, because then that might get a little flimsy. I mean, I doubt it would, but I'd hate to do that and it didn't go the way I wanted. So I can always take off stuff later. But anyway, this project isn't really something that's really going to be finished anytime soon. It's just kind of a final destination of any somewhat dead cells that I have that I don't really want to use for anything else. I'll just slowly start filling it up as I get more cells. Well, anyway, I hope this video was enjoyable, and I hope it was good food for thought. I'm pretty happy with how my battery turned out. I mean, I wish it hadn't broken in the first place, but at least I still got it as a usable battery. And nothing can really replace it. Nothing ever could replace it, but oh well. I'll see you guys later. Bye.